Before heading into the last two examples, let's recap where we've been. First off, the definition. The combination function f plus g is defined by the following. F plus g of x is equal to f of x plus g of x. X is in the domain of f plus g, provided that x is in the domain of f and x is in the domain of g. The difference function was defined the same way. Let's move on now to example 3. In example 3, we are defining the product function, the multiplication function, f times g. Of course, we define it in the same way. F times g of x is equal, by definition, to f of x times g of x. The domain of f times g. This is for all x. That little upside down a means for all. Or you could say that, put it this way, it means the same thing. The domain of f times g is equal to the set of all x such that x is in the domain of f and x is in the domain of g. So it's the same restriction on domain that we've had for every function we've defined. Okay, let's take a look at an example of the product function. It says for f of x is 1 over x plus 1 and g of x is x squared plus x. Find and simplify f times g of x. And then it says, what is its domain? Okay, well, let's find it. By definition, f times g of x is equal to f of x times g of x. F of x in this case is 1 over x plus 1 times g of x, which is x squared plus x. Now, x squared plus x factors. It factors into x times x plus 1. So we could write this as 1 over x plus 1 times x plus 1. And then the x plus 1 on the top would cancel the x plus 1 on the bottom. And we would get that f times g of x is just x. Well, boy, it would be a lot easier evaluating this than it would be to evaluate these two complicated functions and then try to put them together in a product. So you can see the benefit immediately of forming a product function. Now the second part says, what is the domain of this product function? Well, the domain is all x which are in the domain of the individual functions. If you just look at this answer, it looks like the domain is all x. You're not dividing by anything. You're not taking any square roots. There's no restriction on the domain. But you have to remember this definition. It's very important. The domain of f times g consists of numbers in the domain of f and numbers in the domain of g. So let's take a look at numbers in the domain of f. Now, all numbers are in the domain of g. There's no division here. There's no taking square roots. But what obvious number is missing from the domain of f? Well, the number -1. Because if x was to be -1, you would be dividing by 0, which means f of x would not even be defined, so therefore f times g of x would not be defined. So we would say the domain of f times g is the set of all x such that x is not equal to -1. Doesn't show up after the product is formed and simplified. You have to look at the function before you combine them to know that x will not be in the domain of the product function. Okay, let's take a look at our last example. This is the quotient function, and this completes the 4 basic operations: add, subtract, multiply, divide. The function division function is the same as the other 4. F over g of x means f of x over g of x. What is a little bit different is the restriction. Now, in all the other problems we'd said, x has to be in the domain of f and x has to be in the domain of g. Well, that still holds. For the quotient function, x still has to be in the domain of f and x still has to be in the domain of g. But now we get a third condition, and that is and g of x cannot be 0. And that's so that in the quotient we won't be dividing by 0. So let's go ahead and take a look at f over g of x. For f of x and g of x, find f over g of x and give its domain. So let's first find f over g of x. Didn't mean a capital F there. Let's first define f over g of x. That would of course be f over g of x equals f of x over g of x, which is equal to 3 over 2x divided by x plus 1 over x. Now you know when we divide fractions, we invert the second fraction and multiply. So that would be 3 over 2x times x over x plus 1. And the x's cancel, and you get 3 over 2 times x plus 1. Well, an obvious number not in the domain of f over g is negative 1, because then we would be dividing by 0. So if we start off, the domain of f over g is the set of x's such that x is not equal to negative 1, that's for sure. Let's see what else might be illegal. We go back to f and see that if x is 0, 0 is not in the domain because f would be undefined at 0. G has that same limitation. It's also dividing by x. So x is unequal to negative 1. It's unequal to 0. And that would complete that computation. And that closes the podcast.